Thousands of people are in need of organ transplants, but there are obstacles in getting treatment, and there are negatives to receiving transplants too. For people who do receive organ transplants, they will have to take drugs to lower their risk of rejection, while also compromising their immunity and still inevitably experiencing rejection and hospitalization on a regular basis. Organ transplants don't even work for everyone. Not everyone's eligible. Those who can't receive transplants receive artificial organs or treatments with even more drawbacks. One solution is to make your own new organ out of your own cells. The first step is to decellularize an organ. It doesn't have to be your own. It can be from a donor or a similarly shaped mammal like a pig. The organ is then connected to a perfusion system, which pumps its blood vessels with detergents, enzymes, and so on to decellularize it. It's done in this way to distribute these solutions evenly and leave the decellularized extracellular matrix, or DECM, intact, along with its smaller structures. Extracellular matrix, by the way, or ECM, is just material found in your tissues, excluding cells. So matrix includes things like proteins and sugars. It acts as a scaffold that supports your cells and helps them differentiate and keeps them separated from one another. This DECM ghost organ will be seeded with your own cells, specifically stem cells, to generate a new organ for you without the risk of rejection. At least that's a simple way of putting it. In case you didn't know what a stem cell is, a stem cell is a cell that's not specialized and can give rise to different kinds of cells. How do you get them? One way of doing it is deriving them from adipose tissue, also known as fat tissue. One problem that has to be addressed is how to get these stem cells to differentiate correctly and colonize the ghost organ. Different tissues with different functions have to be grown under different conditions, and because organ regeneration is so complex on a whole organ scale, it's done in vitro or in a lab setting. The process isn't perfect yet. An entire functioning human organ, has yet to be generated. However, the research has proven to be applicable to injury repair. Decellularized extracellular matrix can be used in vivo or in a living patient to help cells migrate to and attach to an injury. The end goal of being able to regenerate an entire organ has yet to be fulfilled, but leaps and bounds of progress have been made in research, and it really is a promising concept.